Hello, welcome to Basics of Biostatistics fourth video. I am Omar Amin Mohammed from Department of Biological Sciences, Bauchi State University, Gado. In a previous video, we talked about tabulation, where we said we present data in table forms in two forms. It could be simple or it could be complex. We give an example with a simple frequency distribution table. Now, for large samples, we can't use simple frequency distribution table to represent the data. We need to divide the data into groups or intervals or classes. The following are to be determined when dealing with such a number of data. The number of intervals represented by k, and there is a commonly followed rule which is 6 is less than equal to k, which is less than equal to 15, or you just apply the formula. And the formula is k is equal to 1 plus 3.322 log n. Your n is the number. Now, we also need to calculate the range, which is the difference between the largest and the smallest observation. We need to calculate the width of the interval represented by W. The class interval generally should be of the same width. Thus, if we want k interval, then W is chosen such that W is greater than equal to, or you can just say equal to, our range divided by interval. Example. Assume that the number of observations is equal to 100, meaning your n is 100. So if you just apply it in our formula, we have k is equal to 1 plus 3.322 log 100, which gives you 1 plus 3.22 times 2, which is approximately 8. That's 7.6 when you round it up to a whole number. Assume that the smallest value is 5 and the largest value is 6 to 1. You just substitute the smallest from the largest, which gives you 56. So now our width is equal to 56 divided by 8, which gives us 7. Now, we also need to calculate cumulative frequency. It depends on the kind of table we're dealing with, and it can be computed by adding successive frequencies. And cumulative relative frequency follows the same rule by adding successive relative frequency, while the mid-interval or the midpoint can be computed by adding the lower bound and the of the interval plus the upper bound, and you divide it over 2. Now, this is an example of a table which is using 6 class interval, and here the width is 9, and you can see the midpoints here. 30 plus 39 is equal to 34.5. That's how you get your midpoint, or you call it X, or you call it mid-interval. Or if you have a frequency like this, for this particular class boundary, 30 to 39, you have 11 frequency. So you total the number of frequencies, it will give you 89. So now for cumulative relative frequency, you add the first value is 11. So the first value is going to be the first cumulative frequency. And now 11 plus 46 is going to give you 56. So you keep adding successive numbers. 56 plus 70 is going to give you 127. Now, for relative frequency, what you do is you divide the first value of the frequency, which is 11, by the total number of frequency, which is 189. 11 divided by 189 is going to give you 0.0582. And 46 divided by 189 is going to give you 2.434. Now, the same thing you do for the remaining numbers, and the cumulative relative frequency, you start with the first number of the related frequency, which is 0.0582. Then you add it with the second value, which is plus 0.2434, and it will give you 0.301. Now, how you know whether you are right or you are wrong is if you add your relative frequency all together, is going to give you 1, and your last cumulative frequency is going to give you 1. So basically, this is the end of the fourth video. Cheers. See you soon.